According to the National Electrical Code Section 422.30, for appliances over 1250 watts, the branch circuit switch or circuit breaker shall be rated at not less than the appliance rating. For appliances over 1250 watts and up to 50 amps, the branch circuit switch shall be provided with supplementary overcurrent protection. Supplementary overcurrent protection typically means a fuse that is installed in addition to the circuit breaker. However, in some cases, a circuit breaker can provide the necessary overcurrent protection without the need for a separate fuse. The National Electrical Code Section 422.31 clarifies this by stating that the disconnecting means for appliances rated over 50 amps shall consist of one of the following: firstly, a circuit breaker; secondly, a fuse switch; or thirdly, a circuit breaker and switch in combination. In the case of a 4,500 watt water heater, which exceeds 50 amps, the disconnecting means must be either a fuse switch or a circuit breaker in combination with the switch. A circuit breaker can suffice as the disconnecting means for the 4,500 watt water heater, even if it is not within view of the appliance, because the circuit breaker provides both overcurrent protection and a means of manually disconnecting the appliance. It is important to note that the circuit breaker should be clearly labeled and easily accessible to ensure that it can be quickly located and operated in the event of an emergency. In summary, to reiterate the requirements concerning a disconnect for appliances rated over 1250 watts, the National Electrical Code Section 422.30 states that the branch circuit switch or circuit breaker shall be rated at not less than the appliance rating. For appliances over 1250 watts and up to 50 amps, the branch circuit switch shall be provided with supplementary overcurrent protection. Supplementary overcurrent protection typically implies a fuse installed alongside the circuit breaker. However, a circuit breaker can sometimes offer the necessary overcurrent protection without needing a separate fuse. Now, to address appliances rated over 50 amps, National Electrical Code Section 422.31 clarifies that the disconnecting means must be one of the following: firstly, a circuit breaker; secondly, a fuse switch; or thirdly, a combination of a circuit breaker and a switch. This means that for a 4,500 watt water heater, which draws more than 50 amps, the disconnecting device needs to be either a fuse switch or a combination of a circuit breaker and a switch. The use of a circuit breaker as the disconnecting means for a 4,500 watt water heater is acceptable, even if the breaker is not visible from the appliance's location. This is because the circuit breaker provides both overcurrent protection and a way to manually disconnect the appliance for maintenance or in emergencies. Remember to clearly label the circuit breaker and ensure it's easily accessible. This is crucial for quickly locating and operating it during an emergency situation or for routine maintenance. Considerations for selecting the appropriate disconnecting means for appliances involve: firstly, understanding the appliance's power requirements; secondly, adhering to the National Electrical Code regulations; and thirdly, ensuring safety and ease of operation. When evaluating an appliance's power requirements, the wattage and voltage determine the current draw measured in amps. This value is essential for selecting a correctly sized circuit breaker or fuse. The National Electrical Code provides specific guidelines on overcurrent protection and disconnecting means for appliances. Consulting the relevant sections of the National Electrical Code is vital for compliance and safety. Ease of operation and accessibility are crucial for safety. The disconnecting means should be easily accessible and clearly labeled, allowing for quick and safe disconnection of the appliance during maintenance or emergencies. Remember that the primary function of a disconnecting means is to provide a safe way to de-energize the appliance for servicing or in case of an emergency. This disconnecting means can be a circuit breaker, a fuse switch, or a combination of both. A circuit breaker serves a dual purpose. It provides overcurrent protection and acts as a disconnecting means. When a circuit breaker trips due to an overcurrent, it automatically interrupts the power supply, preventing damage to the appliance and the electrical system. Fuses, on the other hand, are sacrificial devices that melt and break the circuit when the current exceeds a certain level. They provide overcurrent protection but do not act as a disconnecting means themselves unless they are part of a fuse switch. A fuse switch combines a switch with the fuse, providing both the disconnecting means and overcurrent protection in a single unit. This is often used for larger appliances or in situations where a separate circuit breaker is not readily available. When selecting a circuit breaker or fuse for an appliance, it is essential to choose the correct size. An undersized circuit breaker or fuse will trip or blow frequently, while an oversized one will not provide adequate protection. The National Electrical Code provides guidelines for sizing circuit breakers and fuses based on the appliance's current draw. The current draw of an appliance can be calculated using the formula current in amps equals power in watts divided by voltage in volts. For example, a 4,500 watt water heater operating at 240 volts will draw approximately 18.75 amps. The circuit breaker or fuse should be sized at 125% of the appliance's current draw. This is to account for the continuous nature of the load. In the case of the 4,500 watt water heater, the circuit breaker or fuse should be rated at least 23.44 amps. The next standard size circuit breaker or fuse that meets or exceeds this value should be selected. Common circuit breaker sizes include 15 amps, 20 amps, 30 amps, 40 amps, 50 amps and 60 amps. In this case, a 25 amp or 30 amp circuit breaker would be appropriate. In addition to overcurrent protection, it is also important to consider ground fault protection. Ground fault protection is designed to protect against electrical shock hazards that can occur when there is a fault between a live conductor and ground. Ground fault circuit interrupters, commonly known as ground fault circuit interrupters, are used to provide ground fault protection. Ground fault circuit interrupters trip when they detect a difference in current between the hot and neutral conductors, indicating that current is leaking to ground. Ground fault circuit interrupters are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. However, they may also be required for certain appliances such as water heaters. Check the National Electrical Code for specific requirements regarding ground fault protection for appliances. When installing a circuit breaker or fuse switch, it is important to follow the manufacturer's instructions and all applicable electrical codes. The circuit breaker or fuse switch should be installed in a panel board or enclosure that is suitable for the environment. The panel board or enclosure should be properly grounded to provide a safe path for fault current. The wiring connections to the circuit breaker or fuse switch should be tight and secure. Loose connections can cause overheating and arcing, which can lead to fire. The circuit breaker or fuse switch should be clearly labeled to indicate the appliance that it serves. This will help to prevent confusion and ensure that the correct circuit is de-energized when necessary. Regular inspection and maintenance of circuit breakers and fuse switches is important to ensure their continued safe and reliable operation. Circuit breakers should be tested periodically to verify that they trip properly. Fuses should be inspected for signs of damage or deterioration. Any damaged or defective circuit breakers or fuses should be replaced immediately. It is also important to keep the panel board or enclosure clean and free of debris. Dust and dirt can accumulate and cause overheating. By following these guidelines, one can ensure that appliances are properly protected and that the electrical system operates safely and reliably. When dealing with electrical systems and appliances, always prioritize safety and consult with a qualified electrician if needed. This ensures compliance with electrical codes and regulations. The selection and installation of a disconnecting means for a 4,500 watt water heater require careful consideration of the National Electrical Code guidelines and local electrical codes. A circuit breaker or fuse switch must provide adequate overcurrent protection and a means to safely disconnect the appliance. The chosen device must be properly sized, easily accessible, and clearly labeled for safe and efficient operation. Moreover, understanding the function and necessity of ground fault protection, particularly in wet locations, is crucial for preventing electrical shock hazards. Regular maintenance and inspection of these components are essential for ensuring the ongoing safety and reliability of the electrical system. Always seek guidance from a licensed electrician to ensure all installations and repairs are performed correctly and in compliance with the latest safety standards. Remember that electrical work can be dangerous, and it is always best to err on the side of caution.